Well, this morning's perfection of this lovely pavlova with raspberry and blackberry might be this evening's disaster if I don't store it properly. Because the meringue, once baked, is quite fussy about how it's stored. It needs to be stored in a dry environment and airtight tin. If I don't do that, it'll go soft and it might start weeping as the sugar takes moisture from the air and oozes out of the shell, and it becomes a very sticky mess. And something similar happens with our AI systems. The process through which we train them creates something that's quite rigid once we fix those weights and those neural networks. So let's have a look at Pavlova and learn about artificial intelligence at the same time. Welcome to Rose's AI. Now, the Pavlova is a bit of a paradox. In fact, actually, I think it's more than one paradox. So we have the paradox of the origin of the Pavlova, which I'll talk about in a moment. But we also have the paradox that, just as with our AI systems, the very process through which we create this lovely crisp shell also creates fragility, which means that systems can stop working in the way that we want them to over time, particularly if they come up against environmental complexities. So let's have a look at Pavlova. So first of all, we don't know where Pavlova really comes from. Now, the Australians would claim that Pavlova comes from them, and the New Zealanders would also do this. What we do know is it's named after the ballerina Anna Pavlova, who toured both Australia and New Zealand in the 1920s. But if you search for the origin of Pavlova, you'll find that both countries claim it, and there's no definitive answer. Now, it's not dissimilar with some of our AI systems, because they're trained on data from multiple different sources, mostly on the World Wide Web. And once the systems are trained and they're producing results, we can't trace back exactly where each data point came from. And we're seeing many cases, many lawsuits, where we see, for example, the New York Times suing OpenAI because it's claiming that OpenAI has used material from the New York Times without its permission to train ChatGPT. We see artists taking issues with systems like Stability AI and Midjourney because their work has been used in these systems without their permission. We're seeing claims made against Copilot. We're seeing claims made against GitHub from code repositories where, again, the people who created the original works feel that their material has been taken without their permission. So provenance is quite something when it comes to both Pavlova and artificial intelligence. So let's have a look at the beautiful Pavlova and learn about AI at the same time. So now let's make our own Pavlova with full provenance. 4 ingredients, 1 baker, total transparency, and then I'll tell you more about the paradoxes of the Pavlova. So in the mixing bowl we've got 4 egg whites. I separated them from the egg yolks a little while ago, and I had to be super careful because a couple of the egg yolks broke while I was separating the eggs, and it's really important. The first rule of meringue, in fact, is that we mustn't have any contamination, any fat, any of the yolk in the egg whites. And if you look at this, you can see that it's liquid, nothing like a meringue at the moment, fluid, we can work with it. Now, this is a bit like our AI model. We can't have any contamination in the AI model because any wrongly labelled data or any bad data will cascade throughout the whole model. So just like with our egg whites that are going to become the meringue, we must make sure that there's no contamination. Now, I've got them in the mixer, and having ascertained that, I'm now going to look to turn this liquid, which is very flexible and adaptable, and we can form it into other things, into our meringue. So I'm going to whisk it and give it some structure. We've now got what we call soft peak stage. So you can see the meringue being whisked up, it's frothy, it's foamy, and it's forming into soft peaks. And this is the stage where we add the sugar. And so in terms of comparing it with our machine learning algorithm and our data, it's still malleable, it's still possible to train the network, it's still capable of learning, nothing's formed, no decisions have been made yet. But now we need to give the meringue a bit more structure. So we're going to add some sugar so that the meringue will hold its shape more. And then we'll whisk it again so that it forms stiff peaks, as we say. So I like to add my sugar gradually as I mix. So I'm going to set it on quite a slow mix and start adding the sugar. And this is 350 grams of sugar, caster sugar. quite a while, and it's now got to the stage of what we call stiff peak. So if I lift it up, you can see the meringue is really quite firm. And if you look in the bowl, you can see a stiff peak. Rather, you probably can't, but you can see a stiff peak hanging off the whisk there. Now, the last ingredient, so we had 6 egg whites, 350 grams of caster sugar. Now, I use golden caster sugar because I actually really like a golden shaded Pavlova meringue. But if you want a pure white one, you need to use pure white caster sugar. And now in this little bowl, I've got a teaspoon of white wine vinegar and a teaspoon of corn flour. And we add these right at the end because the vinegar, being acid, helps to stabilise the meringue, and the corn flour helps to absorb moisture. So I'm just going to pop that in the mixer, pop it down, and mix that in. Whoa! Mix that in, and then we'll start shaping the meringue. Now we've got our meringue whisked to stiff peak stage, and if I take it out, you can see that it's pretty firm for meringue, but still soft and flexible. Now we can't reverse it back to its egg white form originally. We've added sugar, we've added corn flour, we've added vinegar, but it's still quite soft and malleable. So we'll now spoon it out to create the shape that we want from the meringue. Now I want a ring, so I've drawn a ring on this greaseproof paper, and I'm going to spoon out the meringue in line with this ring on the paper. Now I want to put cream and fruit in a rim, so I'm actually going to make a little, like a trench of the meringue, which is where it's going to be a guide for where I'll put the fruit and cream. So we're kind of flattening the top a bit to make this trench fatter over here. Wouldn't do well on Bake Off, would I? Then go over it. I've got this little fork and I like to go around, and then this kind of peaky, spiky effect. And these little spiky peaks. So I'll now put this in the oven at 140 degrees centigrade. It's a fan oven for about an hour and a half. So let's have a think about what's happening while that pavlova is in the oven and it's baking. This transformation process going on. The egg proteins bond and form a rigid architecture. The sugar crystallizes. What was fluid and adaptable and flexible becomes hard and rigid. And it's the same with our AI models. As we train and we start to take all of those possibilities, all those fluid possibilities, all those parameters, and transform them to fixed weights, we can't untrain the model. In both cases, both with the meringue, the pavlova, and with our AI machine learning model that we're creating, once we go through that transformation process, that baking process, we can't go backwards. This was liquid a couple of hours ago, those egg whites in the bowl, and now it's a firm structure. Sounds firm, doesn't it? But actually that's quite deceptive, because if I turn it over, we can see, oh look, there's some bits that have crumbled off there. It's already crumbling under pressure, because it's actually very fragile. The rigidity has made it very fragile. And it's the same with our AI systems. We train them, and then when they're put under pressure, out in the real world, they might have been fine when tested. We get these adversarial examples, we get edge cases where the models behave in ways that maybe surprise us. And that's a feature of the nature of machine learning AI. Once we've trained it, we can't untrain it. And so the transformation process with our meringue, the baking, with our AI models, the training, bakes in particular features that make that flexible, soft meringue that we once had into something hard, rigid, and brittle. And of course there's another challenge both with meringue and with AI, and that's time. Because if I don't store this meringue in airtight conditions, it will become soft, it will crack. And if it's stored in a humid environment, then it will start to weep. The sugar will start to ooze out of the meringue. And so we really need to make sure that we take care, we provide our meringue with the right environment to maintain its perfect, lovely structure as it is now, fragile as it is. And it's true with our AI systems. Once they're deployed, we need to keep maintaining them, and we need to look out for situations when perhaps their fragility is becoming a challenge. And one other thing to mention just before I go on to decorating this lovely meringue, going back to the point about stickiness, there's a real parallel here with technology and the AI systems that are being developed. So when our meringue becomes sticky, it's the sugar that's crystallizing and oozing out as it absorbs moisture from the air. And of course, sugar is one of the very addictive qualities of our meringue. It gives us a sugar rush, immediate satisfaction. And of course, technology systems can be exactly the same, almost like a sugar rush. Your brain lights up and you get that dopamine hit and you're addicted to this particular tool, or you can become addicted to this tool. And of course, just as our sugar, delicious as it is, it's not very nutritious and it's not sustaining us. We also need to be careful that our technologies, our AI systems, are not just tools that we find addictive, because often they're designed for engagement rather than well-being. And ask yourself, when you're using one of these tools, is this something that is doing something for me, or is it a little bit of a trap? Because we need to make sure that the tools that we're using are useful for us and not using us. Now we're ready to decorate our lovely pavlova, and I'm going to add some cream. This is actually cream that I've whipped up with a little bit of vanilla essence and a little bit of icing sugar, just because I happen to like a little bit of sweetness added to my cream. So I'm just going to pop this round in that trough that I created before I baked this pavlova. I don't know, different people like different amounts of cream, so obviously you will decide for yourselves how much you like. I think I need a little bit over there. The fruit isn't particularly great in the shops at the moment, but I did manage to get some lovely blackberries and just a few raspberries to add a bit of colour. So obviously decorate your pavlova in whatever way you like. I like to be quite random, but I always start off in a kind of organised way. But there are many things that we can learn from making a pavlova, and as always with my videos, I like to give you 3 things to think about in particular when we're baking and learning about artificial intelligence. So my first point when it comes to pavlovas, paradoxes and artificial intelligence is that you need to ask yourself, in all cases, can you trace the origins of the ingredients? Do you know the quality of the eggs, the sugar, corn flour, vinegar? Can you trace the provenance? The same with our AI systems. Can you trace the provenance of the data? Do you know that it doesn't include harmful data, that it's pure? Remember when I was talking about the egg whites, making sure we didn't get any yolk in there because we can't have any contamination. So that's the first point. The second one is to recognise that soft, flexible, malleable starting point, which we gradually whisk up with our meringue to make it firmer, in the same way that we gradually train so that we can fix weights in our networks for our AI. Once we make the transformation, baking with the meringue, becomes hard and brittle, and then it can become very fragile. And so we need to be aware of the fragility that's created through that transformation process. And then the third point to remember is that of course systems can degrade in the same way that my meringue can degrade and become sticky as the sugar oozes out, and it's almost clinging to me when I touch it. It's the same with some AI tools. They can become addictive. And we need to be very, very careful about that, to recognise that in many instances we're experiencing technologies that are designed to be addictive, just in the same way that sugar rushes can be quite addictive. So make sure that you remember those 3 things. Can you trace the provenance? Remember that flexibility that transformed into something hard and rigid can bring fragility, and that stickiness can be quite addictive, and it's something that we need to watch out for. So whilst I still can't tell you whether the pavlova really originated in Australia or New Zealand, what I can say is that both with pavlova and AI, provenance matters. The hardness that we create also brings fragility, so the perfection has a bit of an expiry date on it, and once it becomes sticky, it's not necessarily useful, addictive as it might be.